Hello everyone, welcome back to another physics video. Today we'll be continuing on our equations and seeing how they work out. Today I'll be picking a more challenging problem and seeing how you guys do. So let's say we have a cliff. That's how usually all of these problems go. And you're standing on this cliff and you throw a ball. Let's say you throw, and it's gonna be around it's gonna be around like this. Like this. And so this is going to be our coordinate system. If I can draw straight lines, our coordinate system is going to be like this. And so let's say this ledge is going to be 30 meters. And let's say this is the general problem. And let's say I give you this distance, let's say 24 meters. Now what would be the velocity? Now it seems like I didn't give you enough information. Well, in fact, I did give you enough information. I just need to tell you how long it took. Let's say let's say it took you 2 seconds. Let's say it took you 2 seconds. For this, just plop, just land like this. Now, is this possible? And if so, what would be the initial velocity? So we can use this equation. We know s as position. Now, why are we disregarding this? Because this is more inverted. Usually, we have time on the y-axis and distance on the x-axis. Like, let's say, for example, if we have, let me go down here. If we have an example like this, and we draw a sketch, and I'm throwing a basketball, time will be here, right? When will be the highest peak, and this is the height. Like how high was it at this point in time? Well, but it isn't like that. Instead, the axes are reverted. So this 30 meters don't necessarily matter. It is very hard to say where it is. So this is more of an accurate representation because at time 1 it's here, at time 2 it's here, at time 3 it's here, time 4 is here. Let's just say, but here, let's say time 1 is around here and time 2 is around here. So let's say this is going to be time 1. Time 1 second, and of course it's down. So this is a bit weird. 0 seconds, and finally 2 seconds. And so we need to solve for u, which is initial velocity, or in my previous video I talked about it being v sub o. Okay, so we say that the displacement, doesn't matter how tall it is, the displacement is 24 meters. So we're going to say 24 meters. 24 meters is equal to, we don't know the initial velocity, so let's just make it v sub 0. But we do know the time. The time was 2 seconds. Now, why did I say 2 seconds? The reason why we say 2 seconds is we are having everything in point of reference. We're saying that at position 24 meters, it took 2 seconds. If we were to say at position, let's say this is 10, because it's exponential decay, 10 meters at 1 second, then we would put 10 meters and 1 second for time. So again, I'm using the second equation. And let's put a plus sign. 1 half at squared. Let me see if I can move this a little bit more. 1 half at squared. Okay, 1 half, that's pretty simple enough. And we multiply by times squared, well, 2 squared. Here, let me change the color. 2 squared. And what is the acceleration? Well, the acceleration with most of these problems is going to be gravity. And I'll write in a different color. Gravity is going to be equal to negative, usually, because it's going downward. But since our point of reference is going downward, this is not applicable. This negative value is not applicable. But just in a general sense, if I'm going to throw a ball, just in general, if I'm going to throw a ball like this, gravity is going to be acting downward on the ball. So gravity is going to be downward. But since our problem is generally downward, we don't need to say negative sign. But just for the sake of the argument, I'm going to have negative sign. So negative 9.8 meters per second squared. So we're going to write, instead of negative 9.8 meters per second squared, since we're looking downwards, gravity is actually helping us, positive 9.8 meters per second squared. And now what we're going to do is just solve for the initial velocity. And so this is just a general algebraic equation with a single variable. So let's simplify this. Seems a bit messy, so let's change this. 24 equals 2 v sub o plus 2 squared is 4. 4 times 1 half is going to be 2, and 2 times 9.8 is going to be 19.6. And the units will cancel out. You know what? I'll do that. Meters, and this is 2 seconds. So 2 seconds times meters per second will also give meters. So the units cancel out. If you subtract 19.6 from both sides, you will get 2v sub o has to be equal to, here, let me do the math, 4.4 meters. Let's see if that's correct. Yes, it is. And finally, v sub o is going to be equal to 2.2 meters. And we'll try another one. This one's going to be hopefully a bit more challenging. Now, what we're going to have, here, let me have a ledge here. Let's say 30 meters. And you're standing on this ledge. You're like a little small speck. And you throw a ball like so. But now what's different is what you're going to do is you're going to have a laser pointer. Here, let me pick a red color. You have a laser pointer. It's going to be pointing in this direction. And it reads that this distance is 50 meters. 50 meters. And last but not least, we will say that the final velocity is going to be equal to 10. The final velocity, here, let's make it a bigger number. Let's say 54. I'm just having a random number, meters per second. Number 1, is this possible? And we're trying to find v sub o. And hopefully time. Let's see if we can find time. Now, we still have the time here and the meters in this area, And let's say this is equal to 0, negligible. We need to try and find the distance or position. So we are trying to find position or x, like always, like in algebra. Well, we can use Pythagorean theorem. We can see that this is a 3, 4, 5 triangle. 3 is to 4 is to 5 triangle, where 5 is the hypotenuse, and it is being multiplied by a factor of 10. So that means that this length must be equal to 40 meters, right? Because the ratio of 3 to 4 to 5. 3 squared plus 4 squared equals 25. The square root of 25 is 5. So this has to be equal to 40 meters. And how do we get V sub O? Well, that was just like the earlier problem we were talking about. We have 40 meters. We have 40 meters is equal to, we don't know what this is, and we don't know what time is. So let's just write that down. V sub O times whatever time is, we don't know what time is, plus 1/2, and since gravity is on our side, let's multiply by 9.8, and of course we still don't know what time is. Well, there's another equation that we have that is the third equation, which doesn't have anything to do with time. It just says the initial velocity and final velocity is equal to these two. Well, that's not helpful because we don't know what the, we that's what I meant to say. We know the final velocity, so we can solve for this. So let's go ahead and do that. It basically says, let me just rearrange it so that there's no negative numbers. We have final velocity, so 54 squared equals initial velocity, velocity squared, plus 2 times a times the position. So 2 times 9.8, have it in a different color, times 9.8 times 40 meters. And we will just solve for V sub 0. And then we can solve for time using the quadratic equation. So let me just pull out my handy dandy calculator and see what this value will be. And it will give us a negative number. So it says 2,916 equals V sub 0 squared plus 784. Whew. If this was a negative number, V sub 0 would not exist. This problem wouldn't exist. So now we can subtract 784, and that will give us a number of 2,132, and that equals V sub 0 squared. Now we're looking for V sub 0. How do we get V sub 0? Well, obviously you just need to square root this value. So here, let me keep going on my calculator. 2,132. You take the square root, it will be approximately V sub 0 will be approximately 46.1736. Well, that's not all. Okay, so we have V sub 0, and we will just 46.1736, 46.1736, and units meters per second. We also need to find time. Now this is a bit of a tedious process, and I will give you the rest, because this video is already too long, and I'll just set it up, and you can use the quadratic equation, which I'll provide you, to solve for time. So we have this equation, and usually we start off with the highest coefficient, but first off, before we do anything, we need to set this side equal to 0. So let's just, and also while we're at it, plug v of 0 into this equation. So let's say 1/2 times 9.8, which is 4.9 t squared, plus, and for simplicity, let's just say v sub 0. Let's just for simplicity say v sub 0 of time minus, because we're subtracting from both sides, minus 40 equals 0. And v sub 0 is going to be around 46. So tell me, is this possible or is this not? You solve for time using the quadratic equation, which is equal to negative b, which is v sub 0, plus or minus the square root of b squared minus 4ac, all divided by 2a. And I'm just going to approximate this to make this more simpler, and this is going to be x, or in this case, time. And this is going to be approximately, we're going to change v of 0 to just around 50, and just because I'm lazy, around 5. So let's see, negative 50 plus or minus 50 squared, which is 2,500. 2,500. Now we have to multiply 5 times 40 times another 4. So 4 times 5 is 20. 20 times 40 is 800. 800. And now we're going to just divide the whole thing by 2a, which is 2 times 4.9, which is 9.8. 9.8. And we simplify this value. This value the square root of 1700 is 41.23 blah blah blah. So let's have a thought experiment here. If this was positive, since negative 50, numerically, the negative 50 is much lower than 41, it will yield a negative number. So let's say this is just regular 41, and this is 10. This will yield a time of negative 9/10. There's another solution. That's a huge comma. There's another solution. If it is negative, this will be an even bigger negative number, which will be approximately negative 10 seconds and negative 9/10 seconds. So even though we found v of 0, is this possible in the real world to have negative time? No, it isn't. And I hope that's helpful.